This conference will now be recorded.
Hi everyone, welcome to the IWS training program, and we'll be talking about PySpark, that is data processing technology, and the recording part is in Python. So combinedly we call it as PySpark. We started with basics of PySpark yesterday, where we loaded a CSV file into one of the data frame, and then we applied few transformation over that. Like we did select, we did filter, and we added a new column, we dropped an existing column, we printed the schema. All these things we did yesterday. Today's agenda is like more advanced topics in PySpark. So we'll talk about how to join in data frame. So maybe we will create two data frames, and then we will be joining them based upon some common joining column. We'll talk about group by in data frame, aggregate functions in data frame, window functions in data frame, Spark SQL in data frame, write data frame into local file, and write data frame into S3 file as well. Yesterday we talked about how to read the input data into a data frame. After that you will apply a lot of transformation over it, and once you have finalized your output, once you have you can say received the actual output, right? It's time to finally store that output into some persistent storage, that can be local file or that can be like on cloud. You can directly store into S3 as well. Okay. So before we start with today's practical, first of all, I have to make sure that my Cloud9 is in working state. So just give me a moment. I need to log in. Then only I will be able to open my Cloud9. Okay, so Cloud9 is configured in such a way that if it is inactive for 30 minutes, the underlying EC2 instance will be automatically stopped. That's a good thing, right? So today we are starting now the Cloud9, and it will automatically start the EC2 instance for you. And within 2 minutes, uh, your Cloud9, that is your development environment, that will be ready. Okay. So in the meantime, it is opening. In case you are having any doubt till now, any theoretical doubt, you can ask me. So yesterday I uploaded one file, I think employee CSV something, right? Today we will upload one more file, I think for department, so that we can create two data frames, and so that we can join them based upon some column. So it is opening my Cloud9. In the meantime, let us have a look at the first slide. Okay, you can see this one. So I have two files basically. I am declaring two variables to making it simple. So employee file path is equal to this, and department file path is equal to this. Then employee df is spark.read.csv will provide the employee file path. Header is equal to true. Infer schema is also true. We talked about these two properties yesterday, right? It will consider the first line as header, and it will automatically detect the data type of the columns from the data itself. Similarly, we can load the department file into the department data frame, and then we can even display them. Employee data frame dot show and department data frame dot show. After that, we will be joining them, but before that, let's create two data frames first. So I'm coming back to cloud now. Cloud9, it should be ready. Yeah, it is ready. Let me do one thing. I will go to file and upload. I will upload one more file today from my local system. CSV file, right? CSV. Employee, yesterday we uploaded this. Let's, okay, that's good. So what we will do is, first of all, we'll go to Spark folder. Yes. We'll go to bin. Hold on, let me check. Okay, inside that we have the actual Spark which we downloaded and extracted yesterday. Inside that bin folder is there, and then you can type PySpark. Okay, so Spark session is ready, and yesterday we executed a few commands. I don't think they are available in the history or not. I think they are not available. Okay, we have to type it. It's fine. So we will open one more terminal. Okay, we'll go to Spark. Okay, pwd. Okay, I will copy the file path from here. So we'll do employee file path is equal to, let's copy the path from here. In case you feel any doubt, right, at any point of time, just stop me and I will clarify your doubt. So yesterday we loaded one file, today I will be loading two. So I will declare this as a variable Spark. Inside that, sample underscore emp underscore data dot csv. Okay, enter. And now we'll make small change. I'm declaring another variable, department file path. Okay, two variable I have declared. Now I will create emp underscore df employee data frame is equal to spark dot read dot csv. We'll provide this path first. Okay, comma, header is equal to true, and info schema is equal to true, bracket close, done. Okay, I think t should be capital. Is that correct? Yeah, true. Okay, that is the syntax of, because that's a reserved word, right? So we have to make small change. The true of t of true should be capital. Similarly, in case you're passing something as false, in that case f should be capital, so t should be capital. Okay, that's good. Let's try emp underscore df dot show. Yeah, that's good. Similarly, what we will do is we will create department df, and we just need to change the path, department file path, and we will give the name as department df. Okay, department underscore df dot show. Okay, that's good. So you can see that department id is the main, you can say, primary column. Department 1, department 2, department 3, department 4, and there is the department name, it, admin, finance, and networking, and department head employee id, which employee is the head of that particular department, his employee id is given there. Right, now what we can do is, if we want to combine, or you can say not combine, we want to join these two data frame, employee data frame and department data frame, that we can do. So I hope you have basic idea about rdbms, where we have two tables and we join two tables based upon a single or multiple columns. And there are different type of joins as well, right? We do inner join, sometimes we do left outer join, sometimes we do right outer join, or even full outer join. Everything you can do here also, but with the help of python programming. Okay, so now I will come back to the slide and I will show you the syntax first for joining two data frames. You can see that I am giving a new name, joined df is equal to empdf dot join department df. and on which column? empdf dot department id is equal to department df dot department id. Department id is something which is common in both the data frames, and based upon that only we will be joining. And the last argument is the type of join. Is it an inner join, or it is a left outer, or it is like right outer, or it is full outer? That completely you can provide. Okay. And after that, in the next line, joined df filtered, because I may not be interested in all the columns, because my employee data frame was having some 1 2 3 4 5 6 columns are there, right? And my department is having like 3 columns, so total 9 columns are there. Out of 9, I may be interested in few selected columns, so I can do select, which we explored yesterday also, right? So let's try this. You can give some name, not mandatory to give the same name. Join df is equal to empdf dot join department df, and then empdf dot department id is equal to department df dot department id. Type of join is inner. Let's try to display this. Joined underscore df dot show. So it will display all 9 columns. You can see here. Employee ID, name, age, gender, department ID, manager, employee ID. These first 6 are from employee data frame. Department ID, department name, and department head employee ID. These are coming from your department data frame. And these are joined based upon department ID. If you want to select out of this, you can do that. So you can give some new name, or you can say selected df is equal to joined df dot select, and you can provide whatever you want. Suppose you want the name as a column name, simple name. Okay. And then department name, suppose we just want to department name. That's all. Sel is selected underscore df dot show. Now it will display the employee name and in which department he or she is working. That's all. You see now. Neeraj, IT, Sahil, Admin, Fortune, IT, Vidya, Lakshmi, Mahesh, everything is there. Okay. So this is just about how to join two data frame, and after joining, how to play around it. You can apply some aggregate functions in case you want to do something, in case you want to select, in case you want to do grouping, that we can do. So I'm stopping here for 2 minutes. In case anyone is having any doubt till now, you can ask me. Rahul, Akshay, Rohan, Saiteja, Hemant. I think now a lot of people have joined. Good to know that. Any doubt from anyone?
No, Neeraj, I'm good with it.
Okay. Thanks, Rohan, for the confirmation. Okay, let's move to the next category, next operation, what we can do. Next is grouping. Group by in data frame. Sometimes we want to grouping based upon department, based upon gender, based upon you can say, I would say, uh, manager, right? Under which manager how many employees are there, or you want to find out which manager is having the highest number of employees under him or her. That's also possible. In that case, you can do the grouping. So you can see here, empdf dot group by gender. Whenever you are doing grouping, right, you have to apply some aggregate function also, because grouping is fine. After grouping, what do you want? In this case, I want to group by gender, and I want to find out the count for each gender. In this table or in this data frame, there are 3 females and 4 males. Similarly, if you want to do the you can say grouping by department, like how many employees are in department 1, how many employees are in department 2, then 3, then 4. That also you can do. Or you want to find out how many employees are under one manager. It may be possible that one manager is handling two departments and each department has further employees, right? So basically manager will have more number of employees, and then because he's managing multiple departments. So it depends like what type of grouping you want to do, and you can do grouping based upon two columns also. Suppose you want to do the grouping based upon gender as well as department. That means in each department, it should display how many males and how many females are there. In department 1, how many males, how many females. In department 2, how many males, how many females. In that case, you are doing grouping based upon two columns. So this way you can do the grouping. Okay, so this is very simple. I'm not showing as practical. You can see here, it is very easily displayed. You can see from the screenshot, group by gender and then count. It's not always mandatory to do count only. You may be interested to do some like I would say min or max or average something. Suppose you want to find out what is the average or average age in male and what is the average age for female. In that case, I'm not interested in the count. Rather, I'm interested in finding the average age for each gender or average age in each department. Something like that you want to do, you can do that. Window function in data frame. What is window function? Window function is basically you want to find out some ranking. Suppose you are generating some result for a university. There can be many students who are having the same number of marks. But even in that case, you have to find out some ranking based upon some criteria that whoever is having the higher age, they should be given the lower rank. And the age is lesser, then you can give another second rank, something like that, right? So based upon the criteria you can create different type of windows. I will explain about this. Let me go back. I will explain what does it mean. You can see that there was an employee data frame which is nothing but directly loaded from the csv file. After that I'm adding one more column to that particular data frame. You can see this empdf dot with column, and what is the name of the column? Rank. If you remember yesterday, we added one more column with the name double A's, and the double A's was nothing but double of the A's of that particular employee. In this case, I am adding a new column with the name rank. And how to calculate the rank? There is one inbuilt function, row number. Row number dot over windows dot partitioned by employee ID. This one. So based upon employee ID, it will be doing your window. So in this example, you can notice that employee ID is repeating, although that should not repeat, but sometime if you have heard about one term, deduplicate. Deduplicate is a process to remove duplicates from your data based upon some criteria. Now you look at this data. Employee 001, Neeraj 36, male, department 2, employee 007 is the manager, right? Forget about the last column because last column is nothing but coming from this rank function. This first six column are coming directly from my file. Then employee 001 is again, name is Neeraj, age is 32, male, department 1, and under same manager. Now you may be thinking that there should not be two records for the same employee, and that is correct. That makes sense. That is the purpose of window function. That is the purpose of deduplication logic. In that case, you will ask your team lead or maybe your manager, right? That whenever we find duplicate, which one to remove? If someone will say, okay, you keep that one which is having higher age and you delete which is having the lower age, because most probably the higher age one can be the latest record, right? In this case, what we want is the first record which is having the age 36, we should keep that, and the second one which is having the age 32, that we want to remove. But how would we remove it? It is not mandatory that every employee will be repeated, right? Some employee may not be repeated. In this case, you can see employee 001 is repeating two times, 002 repeating two times, 3, 4, 5 are not repeating at all. So window function will find out to provide you the rank based upon employee ID. So you can now look at the last column. So this one is rank 1, 36 A's, right? And A's 32 is rank 2. Similarly, employee 002 is repeating, right? So 28 A's is rank 1 and 26 A's is rank 2. And employee 003, 004, 005, since they are not repeating, the rank for them is 111. This is a temporary column. The end user, right? They are not interested in this rank. This is only for our purpose so that we can remove the duplicate. Now what I will do is, out of this data frame, I will put a filter. I will say wherever the rank is 1, just keep that. Rank 2 is this one, right? Delete that. And as we discussed yesterday, you cannot delete the data from data frame. So what we will do is, instead of deleting from this data frame, I will create another data frame with a filter condition. So you can see this. Employee df refined is equal to employee df window, this one, right? After applying the window, dot filter, and rank is equal to 1. That means out of this, whichever is rank 1, just take it out into a new data frame. And if you will display that data frame with the help of show function, now you see that there is no duplicate. Employee 001 with age 36 is kept, another one is deleted. Employee 002 with age 28 is retained and another one is gone. And employee 003, 4 and 5 are as it is because there were no duplicates for those employees. This will be very common use case in every project, because when we get data from different data sources, sometimes we get duplicate data, and ultimately source is fine, you may get duplicate, but in the destination you cannot insert duplicate. That means in between, when you are transforming your data, you have to make sure that you are removing the duplicates based upon some criteria. You should know, like, out of two, which one to keep and which one to remove. Accordingly you will put the logic and then you can filter it out. Okay, so any doubts on this?
Yeah, what is the difference between count and then rank? Both will do the same thing, right?
No, count will count for that particular, you can say, if I talk about this one, suppose you are doing grouping based upon employee id, for example. In this case,
Hmm.
employee 001 has two count, but it is displaying both the record. Grouping will group them together. If I go back to previous slide, right, you see that female is giving 3. It is giving you total count. It's not telling you the detail about individual female. There were 3 female candidates, right? Fortune, Vidya and Lakshmi. It is not telling the detail about those individual. It is just telling how many female employees are there, 3.
Yeah, yeah, got
How
it,
many
got it.
male employees are there, 4. Ranking will
Okay.
not remove any row. In your original data frame there were 7 rows. 7 rows will be still there. Addition to that, we are adding one more column. Does that answer your question?
Yes, yes, Neeraj.
Hey Neeraj, I just
Yeah.
maybe missed that. How can you tell me how you are getting two on that slide?
This one and 2, right?
Yeah. Yeah.
Coming from this function, row number dot over. Row number means rank basically. Over means on which based
Okay.
upon which column. Based upon which column. So window dot partition by employee id, that is your data frame name, and employee df is data frame name, employee id is your column name. So based upon employee id, it will generate the rank. That means wherever employee id is repeating, the rank will be 1 2 3 for them. Whichever is not
And
repeating, you yeah,
okay. Yeah. Okay. So
you
you're
will get
taking
first 2 rows.
employee ID as a reference to get the duplicate
Give the
values,
rank.
right?
Give the rank. So employee 001 is repeating 2 times, right? That means for these 2 rows, rank will be 1 and 2. Ordering also you can
Oh,
see. Order by age and descending. That means whichever is the higher age will get the first rank, and whichever is the lower rank, a lower age, that will get the second rank. Only in
yeah,
case
I
it's
got it.
repeating. In case it's not
Okay.
repeating, then there is no point, because if you look at 003, 004, 005, they will get 111 rank. There is no option of rank 2 because they are not repeating. But in case suppose employee 001 is repeating 5 times, for example, in that case we will sort them, or you can say order by age descending. That means the top one, the highest age, will get first rank, then the second highest will get second rank, 3 4 5, like that. But out of those multiple, whether it is 2 or it is 5 or it is 10, we will keep only the first one, because that's the purpose of this logic. We want to keep uh, whenever there are duplicate records, we want to keep the that record with the highest age, and remaining duplicate records we want to remove. Is
Got
that
it,
clear
Neeraj.
now?
Yeah. Thanks. Yeah, yeah. Got it. Thank you.
Okay, that's good. Okay, moving to the next slide, Spark SQL in DataFrame. Although till now we were writing Python code, but here and there we are doing SQL only, right? Because I am doing join, I am doing order by, descending, group by, filter, right? Ultimately we are doing SQL only. But the syntax is little different. If I directly query on a table, forget about Spark for a second. Suppose I am directly executing my query on Oracle or Microsoft SQL Server. In that case, what I will say? Select star from table, right? If you want to do that type of syntax with Spark, that's also possible. That means from your side you will type select star from table, but behind the scene Spark will convert that into a Python type of code, and it will give you the result. So I will show you that. You can see this one. First of all, you have a CSV file. You will load that file into one data frame, and you will register that data frame as a table, temporary table. You can see this one, line number 12. Employee df dot create or replace temp view. Everything is temporary only, because if you will close your cloud9 and close your Spark, right, everything is gone. There is no actual table, but this will be created as a temporary table. That means you can play with that as a table only. So you can see this, I have given a name, emp underscore table, and now what you do is spark.sql. That means whenever you're calling spark.sql, now inside the bracket you will provide a SQL syntax, not a Python syntax. So what I'm doing is select name, comma, age from employee table where gender is equal to male. Now it's completely like SQL only, right? I'm not doing any dot filter or dot select and then in double quotes I'm providing those things. I'm not doing. I'm writing very plain SQL. So you can do that. And finally you can do data frame dot show. It will display your result. There is no much difference. The only thing is, if you are more comfortable in SQL type of syntax, then very first thing you should do is load your file into a data frame, and from the data frame create a temporary view and give some meaningful name. That meaningful name, whatever you are giving, will be available as a table. So you can suppose you want to join two tables, right? So you can load two files into two data frames, then from those two data frame create two temporary tables, and then play with those tables just like you are executing the commands on RDBMS. You can do joining, grouping, consolidation, union, everything you can do. So it's all about the convenience of the coding. There is no much difference. Ultimate result is same whether you do it with spark.sql or you directly do with spark.select, spark.join, spark.union, group by, window function, as per your convenience. Okay, moving to the next slide. Write data frame into local file. Once you have applied your transformation, your aggregate functions, I think there should be one more slide. Did we miss somewhere? Aggregate functions. It seems like there is some slide missing, because as per the agenda there is aggregate function. Anyway, I will tell you what is aggregate function. So count is one of the aggregate function when you are aggregating the thing, and count is not the only one. You can do min, you can do max, you can do average, like all these things you can do. So if you want, I can show you that. Those are like your aggregate functions. I will show you that. Okay, so let's go with the first one, employee underscore df dot show. Okay, that's good. Now let's do one thing. Let's find out the average for age and group by gender. Okay, so emp underscore df dot group by gender. And as I said, right, whenever you are doing grouping, you need to apply some function. So I will do average AVZ. Let's try if that will work. Either you can take this entire stuff into a new data frame and then do dot show to the data frame, or you can directly do here also dot show. That means you don't need to take into a different variable, you can directly do it here. Okay, that's good. You see that female average age is 23 and male average age is 30. So this is one of the aggregate function, average. If you similarly want to try min, let's check it out first. Male, right? 32, 28, 26, 36. 26 is the minimum for male. Let's check it out. Yeah. Minimum age for male is 26, for female it is 22. So you can apply different type of functions, not only count. So we found minimum, we found maximum, what was that? Average. If you want to find max, you can do that also. And similarly, there you can find many more mathematical aggregate functions as well. Okay, I'm coming back to the slide. Okay, so finally, writing data frame into local file. Once you applied all of your transformation and now you want to write the output into a text file, because whatever you are showing right now, dot show and everything, that is temporary. That is not permanent. Tomorrow, if you will open it again, you have to do it everything again. So once you are done with your work, once you are done with your all the transformation, you should store the output into some file. Just like we have a read function, right? Similarly, we have a write function also. You can see the line number 12. Employee df, I mean whatever is your data frame name, dot write dot csv, and then provide a output file path. It will be writing over there. You want me to try? Let's do that. Okay, so let's do one thing. This one, right? Instead of dot show, I will take it into a variable. Okay, so that I can write that variable. That's my purpose. So I will say final underscore df is equal to this and enter. Okay, now final dot, not dot, underscore df dot write dot csv, because I want to write this file into csv format, and then provide the file path. You can provide hard coded or you can use some variable. Let me now provide some hard coded only. We had some path, right? We'll copy that. I will copy this path, control C, provide here control V, and give some name, final output dot csv, and that's all. Enter. Okay, that's all. So this output, right? This output, female minimum age is 22, male minimum age is 26, should be written into the specified file, and that is persistent storage. That means even if you will close your Spark cell, even if you shut down your Cloud9, the file will be still there. So I am coming on the left side. Where is the file? Do you see? It's there. This one. Okay, so whatever path you will give, right? Okay, that is my bad. So the path you will give, right, that path will be directory name, not the file name. The reason being is because usually we deal with large amount of data. So whatever path you will provide, that would be your output folder path. Inside that you will find the file. As of now, there is a single file with some you can say random name, but in case there is a large amount of data, there can be multiple files as well. To keep it simple, I will remove this because folder name with .csv is very confusing, so I am just removing it. Delete. Yes, and I will execute the command again. I will remove that .csv. Okay. Enter. Now it will create a folder with final underscore op. You can see on the left side, it's there. Inside that there should be a file. You can ignore this file underscore success. This is system file used by Spark to find out whether this operation was a success or failure. For a end user, for a developer, this file has no significance, so you can ignore that. For us, the file is this one, .csv. That is the output file we are looking for. So double click on that and you can see on the right side, because we requested to save this file as a csv, right? That's why you can see that female 22, male 26. Okay, so we stored this out, this final data frame. In between, whatever we did, right, we did grouping, we did joining, window function, each and everything, whichever you want, you can write that into a CSV file. Okay, so this is all about how to write the file. And similarly, if you will provide a path for S3, you can even write your file into S3 as well. You can see here, instead of a local cloud9 path, I am providing a S3 bucket path, and accordingly your data will be stored into the S3 file. Okay, and this is just to show, like, you can go to the bucket and you can verify from there. Okay, that's all for today's class. Anyone is having any doubt?
No, Neeraj. Thank you.